Hi everyone, my name is Dr. Maria Harney and I'm a psychiatrist, scientist, analog astronaut, and a writer. In this presentation, we will be discussing space medicine for austere, isolated, confined environments by looking at training analog astronauts, Mars medic teams in high-fidelity analog missions in Nepal, Himalayas. Missions were organized by MAARS, Mars Moon Astronautics Academy and Research Science. First, let's do a quick look overview of the high fidelity missions we did. On this picture, you see Nepal Mars Medic Crew 001 that was deployed at Aloha Masang, Nepal at 10,000 feet in March 2019. On this one, we see Nepal Mars Medic Crew 002 high fidelity mission that was deployed to Ahmedabad, Nepal in September 2019. This is the first ever analog astronaut mission to be deployed at 15,000 feet. I joined the mission as part of the remote medical team, which consisted of the medical doctors all around the world of all different specialities and living in different time zones, which allowed us to provide a 24/7 uninterrupted mission support to monitor for any issues or any medical emergencies. In these high-fidelity missions, we had mild case of altitude sickness, gastrointestinal problems, psychological and human-related factor issues. One of the crew members experienced anxiety, depression, and that led to the sub-level performance and led to some interpersonal conflicts and overall increased stress level in the crew. Our high fidelity missions weren't as long as the round trip to Mars will be, yet we encountered those challenges. What is the chance of the medical emergency and human factor related issues occurring during the 900-day mission to Mars? According to NASA, it is expected to have at least one serious medical emergency, and it is absolutely inevitable for the emergencies to occur when we settle on Moon or Mars. In this talk, we'll give you several examples of achievements in space medicine, biotechnology, and applied exponential technologies that we implemented in our high-fidelity Nepal missions. And we also look at the gaps that still exist to make the astronaut crew settlement possible and habitat fully autonomous. Let's look at the examples. In the Nepal missions, we have successfully implemented the teleanesthesia and telesurgery protocols using the 3D printed surgical tools and 3D printed ViperJet. ViperJet is a novel 3D printed portable anesthesia device created by Dr. Shikita, and it is a viable solution to perform anesthesia and surgery in space and in isolated areas on Earth. Both medically trained and non-medically trained crew members were observed and evaluated on their skill acquisition, assembling the ViperJet, and skill retention. On the top picture, you see the ISS crew receiving an emailable ViperJet sent from Dr. Shikita, and on the bottom you see the crew using the ViperJet. Some of you probably thinking of the further development of the biotech and 3D printing, and rightly so. We are on a trajectory to be bioprinting fully integrable organs and basically moving towards the personalized medicine approach. Here we have yet another example of the integration of technologies during our Mars high-fidelity missions. For our search and rescue EVA extravehicular activity, we have successfully used an autonomous rover to help search and rescue team in finding an injured astronaut, and then the team performed their triage followed by teleanesthesia and telesurgery. In Mars high-fidelity missions, we also utilized Avatar Medic. Avatar Medic provides real-time remote medical relief. It is the next phase of telemedicine that is capable for the full remote care. It has many components like mobile application, robotic solution, artificial intelligence, biotechnology to support medical triage and procedures during disaster relief. It's likely that in the future we'll see more robotics assisting astronauts in various tasks, and we're going to see some developments more and more in the science of the bionics. As we draw more inspiration from the various biological organisms, we're solving some problems in engineering and space medicine, but we're also collecting an enormous amount of data because we have to acquire the data about the astronauts and the environment, pre-simulation, in simulation, and post-simulation, analogous to pre-flight, in-flight, and post-flight or settlement on Moon or Mars. So all this data needs to be analyzed, it needs to be stored, it needs to be used for the predictive modeling. So artificial intelligence and machine learning helping us with that. So for Mars high fidelity missions, we used Avatar Medic. Another example of such application is being developed by NASA and is called autonomous medical operations. Deep learning and machine learning can be also used in applications like VR, AR, and we also implemented such activities in our missions. It has been used as a countermeasure for the astronauts' psychological and interpersonal problems. Let's divide the stressors in 4 categories: physical, habitability, interpersonal, and psychological. Imagine an astronaut encounter one or several of those stressors and has to perform a medical emergency task. So for us to ensure the well-being of the astronaut and mitigate the human-related errors connected to those stressors, we created special protocols and activities that help us to restore this work-rest balance for the astronaut. One such activity is body mapping art therapy using the 360-degree VR Google Tilt brush. Basically, what it entails is that the astronaut paints an image of himself, of his mental and physical state, and then we collect those images and analyze for patterns. Another application that utilizes VR and AR technology is Burning Mars Love VR project. It is a conflict resolution simulation training that allows us to for the astronaut to go through various scenarios and see the optimal ways how to behave and resolve the issues. It also used for acquiring new skills and helping to determine the effectiveness of protocols and procedures during our simulated medical emergencies. In one high-fidelity mission to Nepal, Mars, crew members worked with the Green Hub, and they reported 20% fewer interpersonal conflicts than in a mission that didn't have a Green Hub. Also, they mentioned the aesthetics and the practical importance. Likewise, the astronauts on ISS mentioned that as well, and plans keeping astronauts healthy on a long-duration space flight. They were able, ISS astronauts were able to grow various of plants: lettuce, cabbage, kale, zinnia flowers. You see some of those pictures on the slides. We also had some success with the lettuce in our Green Hub. So on this slide, you can see the alga-powered photobioreactor. What it does is it converts the carbon dioxide into oxygen and edible biomass through the photosynthesis. So it provides food and it provides oxygen. Very hard to resupply on a long-duration space flight. Another vast subject that will help to propel our space medicine technologies, synthetic biology and nanomaterials and materials with the new properties. Concerning the space medicine, I shall say that synthetic biology tool will help us to manufacture synthetic drugs to fight diseases and effects of the space environment, like radiation, microgravity. It will help us to prevent disease and maintain the human microbiome. Materials with new properties can also assist in developing protective shielding, radiation-resistant clothing, and Mars missions are also integrating synthetic biology in our training by using a CRISPR kits. So as we can see, we make the full usage of these exponential technologies in our space medicine applications, but yet there are many questions remain because human factor predictions are difficult to make and long-term physiological effects of living in space are still unknown. Commercial sector is growing, so we need to be answering a lot of questions in relation to that. Also, subjects like gerontology, sexual relationship, death in space on board of the spacecraft on other planets still to be answered. The main goal is to create an integrated system to ensure the successful human settlement and habitat sustainability. So on the last slide, we see the beautiful picture from one of the Nepal missions. And if you want to learn more, please visit our website. My name is Dr. Maria Harney, and you can reach me at drmariaharney@gmail.com. Thank you.